Yes, the unbalanced load of the light poles could be a contributing factor to the high electric bills. When a three-phase electrical system is unbalanced, the phase currents are not equal. This can cause excessive current to flow in one or more phases, leading to increased power consumption and higher electric bills. It was found that the B phase was rotated among poles, and some poles were connected to different phases and breakers. This indicates that the load on the three phases was not balanced, which would result in unbalanced currents and higher power consumption. By correcting the wiring and ensuring that the light poles are properly connected to the three-phase system, you can improve the load balance and reduce the current drawn in each phase. This should lead to a decrease in power consumption and lower electric bills. In addition to the unbalanced load, the use of 400 watts metal halide lamps may also be contributing to the high energy costs. These lamps consume a significant amount of electricity, and switching to more energy-efficient lighting options, such as light-emitting diode fixtures, could further reduce the electric bills. Now let's delve deeper into why unbalanced loads in a three-phase system lead to increased power consumption and what steps can be taken to mitigate this issue, covering the underlying principles and practical considerations. Firstly, understanding three-phase power. A three-phase electrical system distributes power using three alternating current circuits, each with a different phase angle, typically 120 degrees apart. When the loads are balanced, each phase draws an equal amount of current, resulting in an efficient and stable system. However, when the loads are unbalanced, as in the described scenario, the currents in each phase become unequal. Secondly, the impact of unbalanced loads. Unbalanced loads cause several problems. The primary issue is increased current in one or more phases. This can lead to overheating of conductors, transformers, and other electrical equipment, potentially reducing their lifespan and increasing the risk of failure. Furthermore, unbalanced currents increase losses in the system. These losses manifest as heat dissipation in the wiring and equipment, effectively wasting energy and increasing electricity bills. An unbalanced system also creates voltage imbalances, where the voltage levels across the three phases are not equal. This can negatively impact the performance of sensitive electronic equipment and motors connected to the system. Thirdly, correcting the unbalanced load. The first step in addressing this issue is to correct the wiring and ensure that the light poles are properly connected to the three-phase system. This means distributing the load evenly across the three phases. One approach is to carefully analyze the existing connections and reconfigure them so that each phase carries a similar amount of current. Another strategy is to use load balancing techniques such as shifting loads from one phase to another to achieve a more balanced distribution. It is crucial to use appropriate measuring instruments such as a three-phase power analyzer to accurately measure the current in each phase and identify areas of imbalance. Fourthly, improving energy efficiency with light-emitting diodes. Metal halide lamps, while commonly used for outdoor lighting, are relatively inefficient compared to modern light-emitting diode fixtures. Metal halide lamps consume a significant amount of power and generate a considerable amount of heat, contributing to higher energy costs. Light-emitting diodes, on the other hand, are much more energy efficient. They consume less power to produce the same amount of light, and they have a longer lifespan, reducing maintenance costs. Replacing the 400 watts metal halide lamps with light-emitting diode equivalents can result in substantial energy savings. For example, a light-emitting diode fixture with a comparable light output might consume only 150 to 200 watts, representing a significant reduction in power consumption. Fifthly, the role of power factor. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the current is not being used to do useful work, resulting in increased energy losses and higher electricity bills. Metal halide lamps typically have a lower power factor compared to light-emitting diodes. Improving the power factor can help reduce energy consumption and lower electricity bills. One way to improve the power factor is to install power factor correction capacitors. These capacitors compensate for the reactive power in the system, bringing the power factor closer to unity. Sixthly, the importance of professional assessment. Given the complexities of three-phase electrical systems, it is highly recommended to consult with a qualified electrical engineer or electrician to assess the situation and develop a comprehensive solution. A professional can conduct a thorough analysis of the electrical system, identify the root causes of the imbalance, and recommend the most appropriate corrective measures. They can also ensure that all work is performed in accordance with local electrical codes and safety standards. Seventhly, the cost-benefit analysis. Before making any changes to the electrical system, it is essential to perform a cost-benefit analysis to determine the potential savings and the payback period for the investment. This analysis should take into account the cost of the new light-emitting diode fixtures, the cost of any necessary wiring changes, and the estimated reduction in electricity bills. In many cases, the energy savings from switching to light-emitting diodes can be significant enough to justify the investment, especially when considering the longer lifespan and reduced maintenance costs of light-emitting diodes. Eighthly, safety considerations. Working with electrical systems can be dangerous, so it is crucial to prioritize safety. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. Ninthly, monitoring and maintenance. Once the electrical system has been corrected and the new light-emitting diode fixtures have been installed, it is important to monitor the system regularly to ensure that it remains balanced and efficient. This can be done by periodically measuring the current in each phase and checking the voltage levels. Regular maintenance, such as cleaning the light-emitting diode fixtures and inspecting the wiring, can also help ensure optimal performance and prevent potential problems. Tenthly, understanding harmonic distortion. Unbalanced loads and nonlinear loads, such as electronic ballasts used in some lighting systems, can generate harmonic distortion in the electrical system. Harmonic distortion can cause a variety of problems, including overheating of equipment, increased energy losses, and interference with other electronic devices. It is important to assess the level of harmonic distortion in the system and take steps to mitigate it if necessary. This can be done by installing harmonic filters or using equipment with low harmonic distortion characteristics. 11thly, the impact of voltage variations. Voltage variations can also affect the performance and efficiency of lighting systems. Low voltage can cause the lights to dim, while high voltage can shorten their lifespan. It is important to ensure that the voltage levels are within the recommended range for the lighting fixtures being used. This can be done by checking the voltage at the electrical panel and at the lighting fixtures. If voltage variations are a problem, voltage regulators can be used to stabilize the voltage levels. 12thly, the importance of proper grounding. Proper grounding is essential for the safety and proper functioning of electrical systems. Grounding provides a path for fault currents to flow back to the source, helping to protect people from electric shock and prevent damage to equipment. It is important to ensure that the grounding system is properly installed and maintained. This includes checking the ground connections and the ground resistance. 13thly, considering the ambient temperature. The ambient temperature can affect the performance and lifespan of lighting fixtures. High temperatures can reduce the light output and shorten the lifespan of the lights. It is important to choose lighting fixtures that are appropriate for the ambient temperature conditions. For example, light-emitting diode fixtures are typically more resistant to high temperatures than metal halide lamps. 14thly, the impact of dust and dirt. Dust and dirt can accumulate on lighting fixtures, reducing their light output and efficiency. It is important to clean the lighting fixtures regularly to maintain their performance. This can be done by wiping them down with a damp cloth. 15thly, the importance of surge protection. Power surges can damage lighting fixtures and other electrical equipment. Surge protection devices can help protect against power surges. It is important to install surge protection devices at the electrical panel and at the lighting fixtures. 16thly, understanding the National Electrical Code. The National Electrical Code provides guidelines for the safe installation and maintenance of electrical systems. It is important to follow the National Electrical Code when working on electrical systems. This includes using the correct wiring methods, installing the correct overcurrent protection, and ensuring that all equipment is properly grounded. 17thly, the benefits of smart lighting controls. Smart lighting controls can help reduce energy consumption by automatically adjusting the light levels based on occupancy, daylight, and other factors. Smart lighting controls can also provide valuable data on energy usage, allowing you to identify areas where you can further reduce energy consumption. 18thly, considering the color rendering index. The color rendering index is a measure of how accurately a light source renders the colors of object. A high color rendering index indicates that the light source renders colors accurately. It is important to choose lighting fixtures with a high color rendering index for applications where color accuracy is important. 19thly, the importance of light distribution. The light distribution of a lighting fixture refers to how the light is spread out. It is important to choose lighting fixtures with a light distribution that is appropriate for the application. For example, for street lighting, you want a light distribution that provides uniform illumination over the entire roadway. 20thly, the impact of light pollution. Light pollution is the excessive or misdirected use of artificial light. Light pollution can have negative impacts on the environment and on human health. It is important to choose lighting fixtures that minimize light pollution. This can be done by using shielded lighting fixtures that direct the light downward and by avoiding over-illumination. In summary, addressing unbalanced loads and upgrading to energy-efficient light-emitting diode lighting are crucial steps in reducing high electric bills for outdoor lighting systems. Consulting with a qualified professional, conducting a thorough analysis, and implementing the appropriate corrective measures can lead to significant energy savings and improved system performance. Regular monitoring and maintenance are also essential to ensure long-term efficiency and reliability. Remember, safety should always be the top priority when working with electrical systems.